it's so general that you just can't use it around a place like this. The Hayden survey came through here in about 1874. They were surveying the landscape and making topo maps. They were also doing geology, but they didn't know a lot about the geology yet. And at the end of the booklets that I write with these maps, I always show the Hayden map so that people can compare it to the maps that we're creating too. And the difference between the two maps is stunning. They were moving through and doing a great job, but it was still really early in the game, and they had to cover all of western Colorado. So they were being very general with it. These are the first really detailed geologic maps to come out in this part of western Colorado. USGS has done mapping for years and years, ever since the 1870s, but they've only done a certain number of maps out here. And so when you get a chance, come up and take a look at this map right here. This is a map of Colorado, and it's got all of the 7.5-minute quadrangles listed out, kind of shown. They're all little rectangles that go across the map. There are 1,800 of these that make up the state, and only about 25% of the maps, the potential maps in Colorado have been made yet, and that's in a period of about 125 years. So we've got a ways to go. Kentucky's the only big state that's ever been mapped all the way through. All the other ones, Arizona, New Mexico, Utah, Colorado, Montana, Iowa, throw in any big state you want to. None of them is mapped all the way through at this scale. And so the state map program is a way that the different states can take part in this and actually create resources for the public that everybody can have. Now this right here shows areas where we've been busy, and all of these yellow areas on the map are the places where we've concentrated. Colorado Springs, Glenwood Springs, Gunnison, Durango, Grand Junction, Delta, Montrose. If you know about these places, you know that they're all in the valleys, mostly in western Colorado, and they're all places where there's a lot of adobes around. There's a lot of growth, especially think about Montrose. About 10 years ago or so was growing like great guns. And these are all areas where people want to know about geologic hazards. It's areas where infrastructure is a concern. It's areas where construction materials and things like that are a concern. So we're tending to work in the populated areas of the state, and these are places that need these maps as tools. The other places that are way out and away, even though I'd love to spend my summer up in the West Elks running around, there's nobody living up there, and there's much more limited land use. So we're concentrating our projects where they'll do the people of Colorado the most good. And so it's really a targeted process that we do. Everything that's in blue is what we want to do in the future, and you can see that there's a lot of those. We've had big cuts in our funding over the last 5 years or so, and we don't make as many maps as we used to, but we go out and make about 3 or 4 maps a summer with our program in different parts of the state. And the other things that show up on these maps, the whiter colored areas are ones that the U.S. Geological Survey has already mapped, and so most of them, unless they're out of print, are available through the USGS. And then the ones that are in orange are available through us at Colorado Geological Survey. And what the heck do these maps look like when they come out? Well, this Orchard City one right here, as I mentioned, is going to be released to the public in about a month. It's in its last stage of review right now. We mapped out in the field several years ago. It took about 3 months for us to go around and make the map in the field to look at all the places. And it's been through a number of rounds of reviews, and now it's ready to come out. And when our newer maps come out, they're available over the internet as a free download. All you have to do is just find them on our bookstore, click on it, and it will download over to your computers. If you don't have a computer, or you don't like using computers, you can always contact us and buy it in hard copy form too. We could always arrange that. And the map comes as a sheet like this. It's kind of neat. You can look at it on the computer and zoom in, blow it up, and take a look at that. There will be a second sheet that shows what we call a cross-section. That would be a representation of what we think the geology is underneath the earth, right along a line that goes up through the map. And it would be like taking a big knife and just cutting away the earth and just looking down at the side to see what's beneath our feet right now. So those are always really interesting. And we also put on a 3D representation of this too. So you can really see where are the high parts of it, where are the low parts, and how does that geology relate to the way that the landscape goes. We'll put a short write-up, maybe about 20 or 30 pages, along with these two, and it describes what the units are. It gives pictures of them too, so if you ever wanted to go out, let's say that you wanted to go out and take the kids or the grandkids to go out fossil hunting. Well, we'll describe some of these units, and some of them will say, oh, there are abundant pieces of Inoceremus around. That's kind of like an old clam that existed back in the Cretaceous, and if you knew where that was, you could actually maybe find a place along the highway, or maybe see where we took one of our photos, and you could always go out there and take a look for them. Just a hint for you, if you ever want to find really cool pieces of Inoceremus, just go to Hotchkiss High School. Park in the parking lot there and walk up those two little white bluffs off to the side, and all around the base of them, they've got these big, they were giant clams, and they've all broken apart. It's like somebody came and took a hammer to some dinner plates or something, and they've all fallen apart, but you can find all those shell bits around there. And the edges of the shell almost look like a pie crust. They're kind of rounded, and so we go out and look for the pie crust. So, you know, there's all sorts of really interesting fossils around here. And then finally, for those of you who really use computers a lot and like working with something called geographic information systems, that's a way to bring in all sorts of data and put them all on the same map in layers for it. And our final product will come with all the GIS files we use to make this particular map right here. So you'll get a hard copy version or one that you can just see the way we colored it, and then you've also got these files that you could use any way that you want to. And so we've got different people out there who get these maps and incorporate them into their GIS system. Right now, the Natural Resources Conservation Service, who are the soil scientists in the area, they make the soil maps that you might have seen before. They're really interested in matching up our geology with their soil map, and they think that by putting those together, they've got a more powerful product they can use than their maps standing alone or our maps standing alone. And they're using that to investigate things like the mitigation of salt and selenium loading to the different rivers out here. Maybe by using the geology, we can tell a little bit more about where the selenium's coming from, and we can get a little bit more bang for our buck as far as where we pipe ditches or just where we do various things to stop the flow of those salts into the river.
From a challenge technology